Today, Ken De Cooman, one of the visionary founders of the BC Architects and Studies on BC Materials, is here today to hold a lecture on the topic of upcycling earth as a contemporary building material. BC has been pushing the boundaries of circular and bioregional architecture, construction and education. Please welcome Ken De Cooman.
So, yes, nice to meet you, everybody. My name is Ken De Cooman from BC. So I think I will present probably 45 minutes or something, one project, and then what kind of came out of that project and the general approach of BC. And then, yeah, I would say let's take a moment to exchange ideas, reflections, questions, and so on, so that we can talk further on the subject. So yeah, BC is one group of currently 35 people. BC stands for Brussels Cooperation. In fact, we were students at the Brussels University when we started a loose artistic collective that kind of evolved and evolved and evolved to the collective that we are today. And so, yeah, being active in the stuff that we do already pushed us a little bit without really being our choice towards having to start 3 different legal entities. And I think that's already good to mention from the start, because it shows already that what we kind of today define as the role of an architect, which is to design on paper, give to the contractor, a supervised construction, at least like this it's in Belgium. That's for us, it was not enough to be confined to this narrow interpretation of the role of an architect. And so over the years we had to start, next to the architectural company, we had to also start a non-profit to be able to organize education, also some kind of funding of self-initiated projects also, and also a material production cooperative, which is called BC Materials, as an architectural company in Belgium cannot produce materials. And so it already shows how we need to negotiate and navigate within the kind of framework that society has given us in Belgium, and how we try to deal with that. So this is an image from an exhibition that we did in the art center in Hasselt in Belgium. Just wanted to show it because it nicely brings the topics that we deal with. BC as a hybrid office with different activities. Still, we have teams that we work on. One team here that you see here is geo-sourced materials, or geo-sourced material culture, let's say. It's a bit broader than just the materials itself. Also, everything that has to deal with the culture around the material. So here we see a project in the south of Belgium presented in a model, and in fact in the exhibition we presented the materials that we made specifically for this project, namely earth plaster, ram dirt floor, and different researches on earth plaster and so on, also nature stone for this project. So everything that is unprocessed soft crust of the earth around the project, very local, that we presented here in this room. So geo-sourced. Next one that I'm going to also talk a little bit about today. This is a project in the south of France that we did for Atelier Luma. And so here the topic is more bio-sourced, even though we also did a bit of geo-sourced there. But as a presentation here, we presented it as bio-sourced because we worked very much with agro-waste streams of farmers who have stuff left after the harvest, for example, rice straw, sunflower stems, and the pit of the sunflower that in fact as a waste, and they burned every year on the fields. And so we started to
also take this material stream, this material culture into account to make biosourced material approach for this project. So geosourced, biosourced. And then the third one is what we call urban sourced. Also, the urban setting can be harvested. Also, the urban setting generates materials. These are materials that have been made once already, but that can be reused. And so it's about the deconstruction, the careful deconstruction of existing buildings when we renovate, and to take the components and reuse them in the same project in the renovation or in other projects close by, so that the city in fact becomes like a metabolism where components and elements of buildings are not just demolished, but are being taken carefully and reused in other cases. This is the project that we here presented in this room called U Square. It's a renovation of an old horse stables from the police that currently is becoming a center of excellence for the university in Brussels. So a different change of function. And so, yeah, what we did is, for example, single glazing from the outside windows. Of course, it's not allowed anymore in Belgium today, single glazing. So it was demounted, and we reused that as internal glazing into kind of units, residence units within the building, and like this, sanitary, marble tops, parquet, big bricks, like everything carefully dismounted and remounted in a new design in the building. So yeah, the material cultures around geo, bio, and urban sourced materials, that's something that keeps on coming back at BC and that we really take care of. And then the fourth room in this exhibition was the education room. So it's not only about BC needs to do everything. No. In fact, it's about BC needs to learn everything. And so that learning process that we set up, it's with a lot of people, a lot of partners, and we also want to keep on doing this learning process, not just for us, but also for other people. And so this room was done with the Building Beyond Borders postgraduate that we also have some representatives here in Belgium that work on these topics and that installed this room and as a research, and they made Adobe blocks and so on. And so it shows that the education part, the learning together part, the open collaboration is super important for BC also to make things happen. So that was a small intro. I want to go a bit deeper into one of the projects that we finished last year. I have to make a selection, so it became this one because it shows how as the three topics come together, geo, bio, and urban sourced materials, locally harvested in the Le 8 project in the south of France in Arles. And so you see already here, like the designer team is in fact BC plus Assemble from the UK, plus Atelier Luma, which was actually also the client. So it already starts with this kind of overlapping of roles from the beginning. That's what we like. That's where we can learn the most from each other. That was also directly the case in this project. So Atelier Luma is an organization who researches already bioregional materials in their locality in the south of France, in the Arles region. And so they have already some research done, but mostly on the object scale, like design object, material design scale, let's say, on the different streams that they can reuse to make objects. So here, for example, we see the sunflower harvests being done, and we see plates, small plates as prototypes being made from these sunflower pits. I will talk later a little bit more about it. But also, one of the resources that they studied was the local salt production in the salt marshes of the Camargue region that they also used to make salt panels from, also as a prototype. Algae research Algae is a biopolymer that can be used in different ways. It would also come back in the project, but here just wanted to show what Atelier Luma is doing, and it's making 3D printed objects with bioplastics, amongst others, made from the algae harvested in the region. And so this kind of local, let's say, materials research that they already did was very useful for us because they already had networks, people, craftsmen, and so farmers and so on that we could dive into together with them. And so our challenge was to take this philosophy of local materials research, but to upscale it to the level of a building. We needed to renovate an existing warehouse for Atelier Luma. And so, in fact, making a small object from local materials is a different challenge than making a whole wall or a whole building from local materials. And so we started a big research. Here we see the quarry of Saragan, which is a very soft, very white limestone that was used to make, for example, railings and so on. Very beautiful work that the quarry people were doing. But of course, during this processing of the stone, there's a lot of stone dust that comes free. And so historically, let's say until 50 years ago, this quarry dust was actually used in all kinds of earth plasters and lime plasters in the region. Was very known, was a super good material. However, with industrialization, especially after World War II, that's totally stopped because producers want something that is very controlled within the factory and so on. And so, yeah, this kind of local material was left behind. And so now they're kind of filling up the holes that they make inside the mountain. They're kind of trying to fill it up with the remains of the stone dust that they have, the stone cutting waste. And so for us, this is then one of the resources that we worked with. Another resource that we see here on the left is the actually industrial site for concrete sand. And of course, concrete cannot have silts, neither clays in the concrete, so they need to wash the sand that is being excavated. And so we have this kind of rivers of washed remains, silts and clays when the sand is being taken out for the concrete. That is actually a waste. They have a whole field, a whole river of it. And so in fact, for us also, a very beautiful color. It's again, a resource. It's a geosourced resource that we can totally work with, which is again considered as a waste, unused, totally for free. We don't have to pay for it. It's just there and there's no market for it. And then another part that we used is in fact the building itself. So what you see here on the left is the warehouse during the start of the construction of the foundations. So it's a part of the warehouse. And so also the warehouse itself, we kind of consider as a local materials reservoir that we can use. And so we especially looked into the reuse of the roof tiles, of which some had to be replaced because they were damaged and others could be kept. And so we had a combination of new and old tiles. And then later on, I'll show you what we did with the tiles that were wasted and not being usable for the roof. So yeah, in the end, I show you a bit the low-tech version. We also have the super nice graphic with the computer and so on about this local material research. But I think it's good to see the low-tech approach. You know, you have a map. You have to learn on the go who is active where, and you have to kind of talk with all these kind of people who are actually day-to-day dealing with these streams of waste that are not being used. But there's a lot of knowledge about these waste streams that in fact you have to absorb and introduce into the project. So this is the very important local materials research that we do and that we start with. And so in fact, we don't wait with this local materials research until after we have a design or something. No, like from the first day, that we start thinking about, okay, what's the design brief? What should we do? From the first moment the architectural work starts, we also start this local materials research and directly the prototyping. Because we think that, again, these roles that are the boundaries that need to be crossed. We think that this interaction between materials, between making, and between designing is in fact very important to make it really happen in the project. We often experience that when you start too late with this materials research and prototyping, that it's not possible anymore to get it into the project because of risk, fear, not designed, it becomes too expensive, there's no time, and so on. While if you bring it in from the start, there's all kinds of possibilities to manage all these challenges that it brings. So here we see a model of the warehouse to be renovated. So we have the right bottom part, which is an empty kind of a hallway in the end as a design. We have the left part, which is the mineral, more geo-sourced kind of renovation. And we have the top part, which is the more bio-sourced renovation. And so let's say the right bottom is more used as a kind of polyvalent, multifunctional rough space for prototyping, public events, and so on. Left bottom is more like laboratories, offices, quiet work, let's say, clean work for the Atelier Luma team. And then the band on top is more atelier, loud spaces, storage for the Atelier Luma team. And so like this, we try to zone the different functions that Atelier Luma needed. And so yeah, this prototyping process, if we first look at the top workshop loud spaces, this prototyping on model, but also on a one-to-one scale, in this case with wood, happens directly. More specifically, what was, let's say, the more innovative for this part of the building was the research and the tries and the prototypes that we did with the sunflower agro waste. So after the sunflower was harvested, we have sunflower waste that was unused. And so we separated into the stem of the sunflower and into the pit, the head of the sunflower. And so the stem is a typical very strong fiber that you can use. But however, the pit was the first time for us also and that we had to learn. The pit was kind of, if you crush it, if you mill it, it becomes a kind of polystyrene, flexible flock, let's say, flocking. That was for us, very interesting to use. Another biosourced resource that we used was rice straw. So not wheat straw. In France, there's a legal framework for wheat straw. However, the moment it becomes rice straw, the legal framework doesn't apply anymore. And so we also had challenges here, but the challenges are good, like to work with the engineer, with the insurances, and so on, and to be able to use rice straw in the project. And so yeah, a prototyping process starts. I will show a bit of principles and pictures. We pressed panels with the rice straw. That these panels were used as an acoustic buffer onto certain parts of the wall as a finishing. And you also, of course, see the rice straw bales that were used as an insulation on the inside of the warehouse, which was a nature stone building with lime mortar. And so we had an interior insulation with straw bales. And this resulted in this kind of aesthetics, the straw plus sunflower panel. And here, the green, we see the normal straw panel. So depending on where we are in the space, this is used as a plinth until a certain height or as interior walls. With the sunflower, we also did something quite special. The acoustical engineer in the project wanted to integrate this kind of PUR panels, polyurethane foam panels, in order to absorb acoustics. And so, yeah, we thought it didn't fit into the project. And so we got to know the sunflower pit with its very elastical flocks, kind of polystyrene flocks, and we said, okay, let's try to develop an earth plaster, very rough, with lots of this sunflower material in fibers and pits, and project it very roughly on the wall. And let's see what it gives, straw bale plus this thick textured plaster in terms of acoustical absorption. So we did testing in the lab with the speakers and tested the acoustical absorption. And so we arrived at a value of the alpha is the value, it's 0.35, which is in fact the, let's say, the starting end of the acoustical panel market. So acoustical panels, they go from 0.3 until 0.7, 8, 9, and so on. And so we were on the low end of the acoustical market, so to speak, but we are talking about a wall finishing that covers all of the walls instead of a panel, which is only a certain percentage of the wall surface. And so the acoustical engineer calculated with our lab test results. And so, yeah, we could avoid the polyurethane foam panels and put this kind of textured plaster all over the walls in the space to have a good acoustical performance. Straw bales, just to see the scale of the works. It's working with geosourced and biosourced materials is a lot about logistics also. You have to design the processes to make it happen, because there might not be a supply chain with storage and just-in-time delivery of insulation panels nicely on a pallet that arrive in your construction site. So actually, it's much more than just aesthetical design. It's also material development, but also logistics design to make it happen on site. These are some pictures from the straw bale walls. Yeah, interesting to see is also that we had a part of straw bale walls which were non-load bearing straw bale walls, but we also had a part that was load bearing straw bales. And so you see here the straps that compress straw bales so that they become stable to get to become compression loaded. So it was also the first time that this happened in France with, it didn't happen a lot with wheat straw, but it was totally the first time that it happened with rice straw. And so there was a whole kind of learning process around it to make this happen. Yeah, so in the end, this space becomes this. We have a wood structure that structures a space in longitudinally. We have this acoustical absorbing earth plaster all around these walls and also around behind this this wooden structure. And yeah, that organizes the space into open space and closed workshops for different handlings of materials. These are some pictures from the earth plastering of the straw bale walls. This is the end result pictures of that space. For the other space, the more quiet one, we went into the mineral approach. So a bit less biosourced, a bit more heavy and mineral to prevent acoustical transmission in between spaces and so on. And so remember those resources, the cutting waste from the quarry on the left, and on the right bottom we have the clay from the washing of the sand. And then on the top we have two more materials. On the left is actually crushed buildings from Nîmes, a city close by Arles. And so because the Nîmes buildings are more nature stone, and those are the buildings that are being most demolished now. So what we have is actually a very high quality gravel from the demolition of Nîmes buildings. Of course, we should first prevent to demolish buildings, but if they're demolished anyways, we can use this as a gravel. And then on the right top, we just have a commercial sand. So it's also good to say that 100% of everything is mostly not possible. Sometimes you need certain fractions, certain sharpness of sands, for example, or certain clays, and that sometimes you need to supplement still from non-local materials, but more from the current commercial chains. And so the same principle from the start, we develop, we try on small scale, we go to 1:1 scale, and then test things out. So what you see here is in fact white rammed earth based mostly on this very small cutting waste of the quarry together with a whitish clay. And so this was the base mix for rammed earth in the prototype here, you see on the right. But also you see this masonry. We also made compressed air blocks from it with a little different granulometry. So we had to change the recipe a little bit. But it was very similar kind of materials, let's say. This also goes through the laboratory for testing. So here we test cylinders with slenderness 2:1, so that we're sure that we have the right compressive strength results. And so here we are at above 2 megapascal for these cylinders, which means, let's say, in a normal residential house, a villa, let's say, of G+2, you arrive at a force of around 0.2 megapascal without the safety factors. And so we have a 10-time safety factor for this rammed earth to be used load-bearing in this project, which was convincing also for the stability engineer and also for the controlling office and the insurances. So we used rammed earth and compressed air blocks in this project in a load-bearing way for a G+1 constellation. So also not very high, but load-bearing. And so you see then here that what this gives, as a result, an end result, it's this white local rammed earth. We didn't know beforehand that this was going to be the result, right? It's just like by getting to know the local materials, and in the end, I'm really in love personally with this space. It's when you enter there, everybody says it. It's like the color just welcomes you, a very soft kind of white color, and it's just what the region offers us. There's no design decision where the architect says we need this color. No, it was just what we find. That's what we work with, and that's what the region, the bioregion, gives us. And so I think it's nice and a nice way of considering the connectedness of humans and their environment, and what it means for aesthetics and so on. And so here we are in a constructive system where the rammed earth and the compressed air block walls are loaded by a wooden ring beam that then receives the span of wooden beams and make the span to the edge. And so the edge, if you remember, so on the left is the inside of the warehouse, on the right is the edge of the warehouse. So that was nature stone, but we couldn't load onto the nature stone. So that's on the right side is the part where we loaded onto the straw bales. So they're not very big spans, but still we loaded them on rammed dirt on the one side and on straw bales on the other side. So these are some pictures that show the atmosphere. And then as a third part, it's the reuse, it's the urban source, it's the fact that there is already a warehouse that is there that we need to take care of, and some things we can reuse and put back, some things not. And so here what we see here is the selection of the tiles, the ones which are good and the ones which are not good for use in the roof. And the ones that are good, we put back on the roof and supplement them with new tiles. And the ones which are not good, we do experiments with them to see how can we still use them. And so here we already see two experiments. One is as an aggregate into a lime plaster of the facades, a kind of a rough aggregate. And the other one is cutting them up longitudinally and to use them as a filling and a design element in the floor. So here we see the facade, so the lime plaster render. Yeah, you see maybe the spickles of red of the red roof tiles coming through. The picture doesn't show it so much, but the idea was to show the roof tiles coming back also in the plaster. And then here we see the longitudinally cut roof tiles that are being put on the floor. and that were then made into a terrazzo floor. Here we see the terrazzo floor on the bottom. The resolution is not the best, but you can you see here like the lines that are being used on the floor. And then for us, one very small development that we did, but a very special one, because it introduced us into the world of biopolymers, which beforehand we didn't know anything about. And so by coincidence, we were experimenting with the algae that they collected, Atelier Luma, from the region. And we experimented also with the stone cutting waste from the white stone cutting waste from the quarry that I showed before. And so together with some kind of clays, we were mixing this, and we found out by our own surprise also that in fact these plasters were so strong, they were so resistant to abrasion and impact. And so we really wanted to understand why. And so it introduced us into the world of biopolymerization, and also a little bit into the world of geopolymerization, where in fact the free calcium particles within the finely grounded cutting waste, stone cutting waste, interact with the algae nuts, which are present into the algae residues. And so like this, we could experiment, and we got this green, blue kind of plasters that we then also used in the project. And so today we are continuing with this algae track, let's say, and we're researching and prototyping in other projects, and maybe starting a research project with the university to see where this can lead to. So just to show how, how tracks can be discovered together, and how this can continue after a project is done. Also to say that this is not being done isolatedly. So this is a whole process of development of local materials research that is in fact organized to be done together with people who have knowledge from the region, craftsmen, farmers, quarry people, and so on. And so there's a lot of workshop moments, and these show only 3. A lot of open moments where we meet with contractors, try stuff together, so that we can learn together around these materials. Also with workshops who are more open there was universities that came, architects and so on. Yeah, and I think this is this is in the end the warehouse that was renovated. I think for us it was the first time we worked on this kind of scale, and it really brought us a lot of knowledge. And in fact, it was not only this kind of projects, of course, other projects also, that we learn a lot in these projects. And what we try to do is that the knowledge that we get into these bespoke projects, we try to formulate them and make them available for a wider group of people, to not be only linked to this one project. So that's my little bridge to BC Materials, the material production company. And so, in fact, BC Materials is a result of the knowledge which has been built up project per project over the years of working with mainly for BC Materials geosourced materials, a little bit biosourced materials. And so the concept of BC Materials is like, okay, we did this now for a bespoke project who has the budget and the time and the effort to spend to do this. But what if we want to organize this on a more efficient, productive way for more projects? And so we kind of attached ourselves on what is happening in Belgium in terms of excavated earth. So we're talking about earth from construction sites in Belgium. And so we see that due to construction activity, yearly in Belgium, 37 million tons is being excavated every year. Now, 82%, first I have to say, of that 37 million tons, most of it is non-polluted. So it's a geological soil, undisturbed and unpolluted. There's a 14% which is polluted, needs to be sanitized, but we don't touch that. So we're talking about the unpolluted part. And the unpolluted part, 82% today, so that amounts to up around, I would estimate 25 million tons per year, or maybe a little bit less, between 20 and 25. In fact, today is just like thrown away. Once it leaves the construction site, it's legally considered as a waste. And so they're filling quarries with it, or they're making mountains with it, because there's just not knowing what to do with these amounts of earth every day. And so we said, like, okay, well, let's consider all these construction sites as little quarries. We don't need to open a new quarry if we want to start earth building material production. In fact, we can attach ourselves onto this existing excavations that happen in any case, and that give a lot of problems in terms of transport and logistics and disposal and so on. And so we started out with BC Materials by offering two kinds of production services. One was that with our mobile machinery, we can come to the construction site and transform the earth being excavated on the site directly into building materials. And the other one, so that's this position here on the construction site. And the other one was, in fact, before the transport to the disposal, it's to take in the transport at our place in Brussels, our production hall, and there make stock building materials from it that we're going to sell. And so currently we see that, of course, this is much more economical and much more efficient, because we have our hall, we have our machinery which is installed, and we have trucks coming to deliver excavated earth. And so, in fact, the more and more this is growing. And so for us, why earth building materials? We always say earth building materials is like the case for circular economy, because actually it's circular in origin. So we use not from a quarry, but from excavated earth from construction sites. But also it's circular in destination, because earth buildings materials do not change chemically when they become a product. So cement, the binder is chemical, so once it's done, it changes and it becomes, after a life cycle, it becomes a waste, like concrete waste. But if you make earth building materials, after it has become an earth building material, at the end of its life cycle, in fact, it's still just earth. The binder is still clay. Nothing chemically inside the earth has changed. It has just temporarily been reshaped into a form of a brick, for example. And after the life cycle, it's not a waste. You can reuse it as a brick to make new bricks, or you can give it back to the earth, to the soft crust of the earth. So in fact, there's no waste management related to earth building. And so that's why we say circular in destination. And of course, we don't bake in earth building materials, so it's CO2 neutral. We don't quarry. And so all of these aspects make for us that it's really like a good option today for the problems that, at least in Belgium, that we have, I think worldwide, problems of climate change, problems of resource extraction, problems of pollution because of firing, and things like that. So yeah, earth building materials are also healthy. They're based on a natural cycle, and they create for beautiful spaces. I think since we are with an architecture crowd, I think most of you will know the humidity regulation properties of earth building materials, the thermal inertia of earth building materials, good acoustic performance, no VOC emissions, and so on. And so it's really like it inscribes itself into healthy building kind of interior climates. So if we look a little bit in detail how BC Materials operates, this is a section of Brussels where we have the yellow part, which is called High Brussels, and we have the low part, which is called Low Brussels. You see that there are different colors, which means different geological layers. And so the beige, orange, yellow layers are in fact a sand, Brussels sand. Then that's one of the ingredients that we use. But if we dig in another part in Brussels, we actually dig into the purple and the red layer, which is clays, certain kinds of clays. Just to give you a picture, this is a underground parking garage in high Brussels on top of the mountain, and you see here the sand that is being excavated. Historically, this sand was used for mortaring by all the masons. There were like commercial quarries operating in Brussels region, but with urbanization, of course, in the early 20th century, all of these quarries have closed, and now you don't see anything anymore. Just the street names that refer to Sand Street of, or Sand Market and so on. And so, yeah, today there's no quarry anymore. However, when we excavate, like an underground parking garage, for us, it's like a quarry. For us, it's extraction. And so we kind of take in this waste. Legally, it's a waste. Once it leaves the construction site, we take it in, and we use it in our recipes for earth building materials. This is a construction site in Lower Brussels, and you see here the different color. This is the Ypresian clay layer of Brussels, very strong clay that, let's say 50 kilometers to the north, it's been quarried in a huge open quarry by Wienerberger, which makes the porotherm blocks from it. So it's funny how in Brussels, when you excavate it, it's a waste, but like a little bit further down the line, it's like commercially quarried, and it leaves big scars in the landscape. We also use sand replacers. We use washed, crushed concrete from the demolition of buildings from the Brussels urban environment, because geologically in Belgium, at least around Brussels and Flanders, we're in a lowland area. We only have fine material until 1 or 2 millimeter thick. We don't have the fraction from 2 and higher, and so we need to supplement this, and we do it in this way. And so we created a product range which is called leem. Leem is the word for earth in Dutch language, and yeah, from these resources, there's a bit more than I showed. We produce mixtures which are used for plastering, fine plastering, for paint, also for different kind of ram-dirt mixtures that we see here, and also blocks, all kinds of blocks, different formats, different performances. And so this is a building product range that is made from excavated earth from construction sites in and around Brussels. So this has a website, like a normal product range where we have technical sheets with mechanical performances, tested according to German, French norms, sometimes European norms, so that everybody is okay to work with it, and that we create trust with the architects and the engineers who choose to work with these materials. And of course, we need to think about production. We started very small in 2018, 2019, but we're growing every year. And so we need to think also of upscaling. And so what started out as like really manual work with mobile machinery, very light machinery, to compress a block, to mix a plaster, and so on. Today we have set up, in the past 2 years, we have set up partnerships with industry players. We call it industrial co-working, because it's not that we just subcontract to those people. No, we need to prepare the earths and the recipes. We need to be there with them in order to insert earth in their machinery. And so, for example, here, this is Beton Klaassen. That's a concrete block factory, and it's a vibro compaction technology. And so we insert our earth mixes in his machinery. And so it needs a little bit of hacking and tweaking of the machinery. And so that's what we did in the past 2 years, so that today we can produce in a big enough scale, which means that the price is democratic enough to be used on the Belgian market. Van de Moortel, for example, this is a baked brick factory. And that's another technology. It's molding the blocks, so not fiber compacting, but molding the blocks. And so again, there we work together with them to prepare the recipes, which are specifically for non-baked earth building materials. And we use their machinery to get out industrial adobe blocks. And we don't do this again alone. It's not BC at an island. It's BC in connection with, and these are players from Europe that we link up with and that we exchange. For example, TerraBlock in Switzerland, Feteterra in Spain, Cycletaire in Paris. And so, yeah, we exchange recipes, results, production issues, what to take into account when you use this kind of machinery and so on, in order, yeah, to make sure that we grow together in Europe in different places. So that's a kind of a different logic than what is currently normally happening with a big company, multinational company that chooses to go into a new product and puts millions in it. This is more like a kind of a community, grassroots, bottom-up kind of approach, where the scale-up comes with the dynamics from the bottom, instead of a big company that starts from the top and puts millions to set everything in place. So we believe that this is a valuable way of doing the scaling up. So yeah, we did a block research before we started this industrial co-workings. We did a block research. What can be done with earth blocks in Europe? We went around. I think we visited almost everybody who was busy with earth blocks one way or another at that time. And yeah, we made our choices, which are often informed by kind of basic principles. Here we see a brick from Belgium extruded, but non-baked. Remember the color of the Brussels clay, and the same block, but baked. And so we see that there is knowledge of earth and clays already present in industry. We just need to link it to non-baked earth building products and work together to get the good results. So this is one of the facilities that we work together with. This is Van de Moortel in Belgium for the molded block technology. Again, the same factory, different production line. And this is the Vibro compaction facility in Belgium that normally produces concrete blocks, but here produces earth blocks from the machinery. And so we have our little mobile machine, which produces 1 block per compression. And so we can produce 1,000 blocks per day with 3 people. Here in this factory, we have 50 to 60,000 blocks per day with 1.5 people. So yeah, you already immediately see what is at play here in terms of costs and democratization of the materials and so on. So yeah, the price really changed after we switched to this industrial co-working. It's fun to see again that networks and people are very important. This is Freddy. Freddy, the older guy in the middle. Freddy started in the 60s on his own in the time when you could still start a business in Belgium without a lot of capital. And he started with his mobile machine also to make concrete blocks. And so Freddy and BC Materials really vibed because he saw how we were busy with our small mobile machine, and it made him remember his early days. And so yeah, you need this kind of personal relations to make these collaborations successful. So it's not only machinery and technology, it's also human connectedness that is very important. And so these are his 2 sons, Nico and Bram, who are actually today with the 2 of them running the factory. So Freddy is 75. He's not really working anymore. He just gives a bit of an oversight. But the 2 sons are running the factory. This is Rodrigo from TerraBlock, the Swiss company. So the exchange and the helping each other is very important. So then here we have Nicola from BC. So you see in this picture, I was there, Nicola is there, but there's a lot of other people who are needed to make this work. These are some pictures of the blocks. And then, yeah, as a last material that we're now actually at the end of development that we're going to launch in 2025, it's poured earth. And in fact, we see it as well as an earth screed, which you can cover with a finishing such as parquet or tiles, but also as a finished floor that you can make into a earth terrazzo and so on. And so we really see a lot of potential here. Again, it's the same philosophy. How do we insert earth into our current construction, current building culture of Belgium? And so we really work together with how things are done already today for what people know, that people know today concrete, right? And so we totally develop the material specifically with the right granulometry, with the right viscosity, so that it can be pumped with the machinery that the people know today, because that's the only chance that we have to replace materials. It's to make sure that we don't have to change too much to the building culture, because changing the building culture, that's a 30, 40-year program. And so we try to like hack the existing building culture and insert earth in it so that we can change, replace the fossil fuel intensive materials with earth building materials. You see here a concrete mixer and a concrete pump, and then the typical procedure of pumping it and then pulling it, like we saw on this picture. So yeah, I think that gives a bit of an overview of BC architects, design, architecture, BC studies, education, research, BC materials, material production, and so on. But I think it's important to also go back to the first intuition, the core feeling that we started with 12, 15 years ago. That is that we in fact need to go over the roles that are defined in our current society. If we want to change things, if we want to do things differently, we have to go over the categories that we have installed. So that's why an act of building, we're not calling it architectural projects, we're calling it acts of building. It's taking action. It's also communicating, telling the story to people around it. So the act both as an action, as a narrative. It's to complement, to integrate, to hybridize, to reconnect things that we kind of forgotten during the industrialization of our societies. It's unlearning by doing. We need to kind of unlearn the things that we, for example, can mason with polyurethane foam because it goes so fast and it's so good. No, it's not a good way. We need to unlearn these accomplished ways of doing things, and you can only unlearn not by the head but by doing it together. We do this down to earth. These are like workplace down to earth, but it's also literally, it's being grounded. It's not saying like, hey, we have the newest invention and it's only us who can do it. It's about being humble, collaborating with other people, finding the human connection in everything that you do. But it's also going full circle. It's also putting all of your effort inside it. Also not compromising at the same time, as you have to be very collaborative in order to make these things happen. And so I think that's where we come back to BC as a collective. It's not about a specialization into materials, into studies, into architects or other things. It's more an intuition and an instinct and an attitude that we try to have of continuously trying to evolve and to learn within our building sector and within our material culture. All right, that was it. I hope it was followable by everybody. So I think, if you have reflections of ideas.